Hello and welcome. I'm Bill Wake. We're starting today on a new project. Well, it's not quite a project. It's more like some research for a bunch of projects. I'm calling it Spike-a-thon. I've got half a dozen projects I've been considering, and thought I'd do just a little bit of work on each one today, and just see where that gets us. And then probably by Sunday I'll pick a project, most likely one of these. Let me just go through them and we'll see. Yeah, we'll just see where we are from that. Okay, so one of them is an idea for a kind of hardware software project. Somebody gave me this little photon breadboard. It's got a little microprocessor on it, and it is Wi-Fi connected. There's some sort of service you can send messages to and maybe fetch them or do something. I'm not quite sure. My idea was I would take the photo cube and make this kind of timekeeper out of it. So I will label each side, or maybe 4 of the sides or 5 of the sides. I'm not sure how that's going to work, with some task that I'm working on. And maybe this is tracking breaks, or, I want to do at least 15 minutes of exercise before I do XYZ. And just the idea is that I have these sensors in there that detect which face is up, and this thing will send a message every 5 minutes, and then some way to turn it off when I'm not doing anything. And so I don't know if the service is even active anymore. I haven't played with the tilt sensors to see what happens. The photocube comes apart. I guess I've done that much. Let's see. So here's a nice picture. Let's see if I can find. Okay, so the tilt sensor, this is sort of a mechanical kind. I guess they're all mechanical, but in this one, you have this little can with 2 wires coming out, and inside the wires don't connect, but there's a little ball that bounces around. And if you have the thing fully upside down, the ball's at the far end here, and it doesn't make a connection, and it, it says you're tilted. You're clearly tilted that way. The other way you can do it is if you put this thing vertical, the ball touches the contacts and makes a circuit, and now you're saying you've closed the circuit. You can turn on the light or whatever you want to do. Okay, so in my case, wherever I got off to, I've convinced myself anyway that I just need 3 of these things, and if I let's see, I think you're seeing my hands. If I crisscross them at kind of diagonals, so imagine each one going from a corner to its diagonally opposite corner in 3D. If I did that for all 3 corners, or all 3 pairs of corners, I think I would have it. And so I think I could say, if all sensors were off, that means it's sitting on the bottom of the cube where, the sort of default position. If they're all on, maybe that's the other way, and maybe some others. I mean, there's 3 switches, so 2 to the third is 8 possibilities, and a cube only has 6 sides. So there's going to be some ambiguity or something going on with that, but all part of what we would figure out for this. And then, I don't know, inside here, you can see the chip. It's on sort of a breadboard, and I can't remember if they give you a separate breadboard or this is all in one, but you can hook up little parts and stuff. They gave you some LEDs and some resistors and whatnot, but hopefully these work. There is sort of an input-output port, and you turn on a certain set a certain memory location, and that says I want to use the IO port, and that. And I should be able to do my 3 bits as 3 bits coming in, although I don't know. It depends how they've organized things. Okay, I don't know much. You'll see a theme here. All right. So that one, what's interesting there is there's going to be a bit of, I think they have a sort of C-like programming language or a subset of C that you would load onto this. And then I might have some analysis software, maybe, you know, make little charts or whatever of graphs, who knows, and see what happened there. So that's that one. Haven't done TDD embedded in a while now. Last I did it was it's probably three or 4 years ago. An energy company doing some embedded systems kind of stuff, and using a C package and C++. Anyway, the next one is a game I'm calling a pipes game, and the idea is, I guess I didn't draw very well, surprise, but over on the bottom left you have the spool of thread, and then I have something coming out, and then F# GED, that's representing notes. So this one, the diagonal line there is supposed to be a little hose and squirting out notes. Okay, so D, E, G, F# is the start of a tune, and the idea is that you would somehow, TBD, make connections between these nodes, and I would like to have you hook up the pipe to, I think most simply you could hook it up to the keyboard and then to a speaker, and you would hear the notes coming out. But you could imagine different devices, different filters, a whole synthesizer worth of stuff if you wanted, that would happen as well, and that could be fed into. So maybe you feed it into some sort of divider that says, high notes are played by the violin and low notes are played by the bass. Okay. And then feed that through some other things. But the idea is you would hook these things up together in interesting combinations. I'm not sure if it's a game or a toy. So what I mean by that is I don't know if you have goals or you just have, things you can play with. So I mentioned Lemmings and Pinball Construction Set, kind of old school games. Pinball Construction Set, you basically got given a bunch of bumpers and levers and, flashy lights, all the stuff you could do, and you could arrange them how you wanted to make a pinball machine. And I guess if you don't know what those are, you'll have to look it up on Wikipedia. But anyway, you create your own pinball machine and then you can play it. And there's Roller Coaster Tycoon. You could create your own roller coaster and play it. And SimCity, you could create your own city and play it. Those are more like toys. There's no inherent goal. I don't know. My memory of SimCity is like build up a city, kind of interesting, and then, see what disasters you can unleash on it and have it fall apart. Not quite sure that's the goal they had for me. A game, on the other hand, has goals. So one of the examples of a pipeline, there's a clever one for spell checking where you feed a document in, you normalize, you sort it, you compare it against a dictionary, and you spit out the ones that aren't in the dictionary. And that gives you your misspelled words. Okay. And we could check, I could feed you a stream of words, and if you classify some as spelled right that aren't, and vice versa, we can see if you've solved the puzzle. All right. I would probably do this in Xcode, Swift anyway, for the iPad, I think. It doesn't seem like it would quite fit on a phone, what I have in mind. And I don't know, I also want some animation kind of things. I'm envisioning these notes like fading out after a few seconds. And I would love to have the diagonal line act like a fire hose where they haven't mounted it, but it's squirting around and, flailing around or something. But I suspect it's enough work to hook up a bunch of pieces and have them actually do something. Okay. Next one. Sources, filters, and sinks. So the source, the diagonal line, spitting out notes, or it could spit out pulses, or letters, or words, or whatever we want to play with. That's the sources. Filters are things that change it. So if I had that filter I described that split it into a high stream and a low stream, that's kind of a filter. And sinks, I guess the speaker would be a sink in this place. It's where things are going. Alrighty. Next one, p-test. Oh, I lost my picture. Anyway, I developed a parameterized test module for Swift. Not a big thing, just, I don't know, it was like 20 to 50 lines or something, but it lets you create arrays of mixed objects that you would feed into a testing framework, and it would run the variations on your test for that. It basically used some characteristics of generics in Swift, and I'd like to kind of clean that up. John Reed gave me some good advice and had some good ideas and discussions on that. So I want to take what his suggestions were into account. And then also I've had this notion of assertions. Equality is usually kind of built in, but sometimes you need some help on that. Hashing, if you test equality in hash for value objects, that's a trick I learned from James Shore. Trick is a code word for technique. But there are other things you want to check. Are things sorted? Are they idempotent, which means that if you apply the function one or more times, you get the same answer every time. So we talk about it with web systems sometimes. It's like reading is definitely idempotent. Reading doesn't change anything, but you could post something, and if you repost it, does it result in the same thing or not? Okay. Associativity, A plus B plus C equals A plus B plus C, and all the other little math rules. I suspect there's probably 20 assertions we could make around stuff like that. So, identity laws, X plus 0 equals 0 plus X equals X kind of thing. Those two, identity and associativity, give you a monad. So if you want to touch on some of the functional stuff, you've got something there. I just think there's an interesting set there. I know I collected some somewhere, and I would have to find those and see what goes. But what I like about this one is I think this could become a package that lots of people might use in the Swift world, and do some good there. So I kind of like that one. Okay, another one. This is more of a phone/iPad thing. My idea is that lots of times I have cards that are written by hand, and I would like to. I'd like to blend the card by hand and the card in my computer more. So my idea is, take a picture, probably on a less busy background than this, but take a picture and break these things up into separate cards. These don't overlap, so that's sort of an easier case. If I've already loaded this set or part of it, match up those cards that I have online to the new card or to the cards I'm taking the picture of. And I said use Magic AI Dust because I don't know how we'll do that. But I have played a little bit with some AI, teaching AI kind of thing. Maybe there's some something we can make use of there, and let you tag them, manipulate them. So I would love it if I could take the arrangement like this, which is sort of it's when we're doing the Elm parser, and the far left is goals, then comments, and so on. Those are sort of that first column is my easy ones, and then my medium ones, and then some harder ones. I think I'd love to arrange them like that, and then take a picture, and then have it reproduce the diagram, maybe clean it up a little as independent cards in my computer, and then I'd like to be able to rearrange the cards here, take another picture, and have it realize like, oh, you've rearranged them, and have it rearrange the cards. And if I had tagged them with something, maybe I translate them or type in the English text if I can't read it because my handwriting is not amenable to that really. But do something on that order so that I get some value from loading them back in, and I think of, I do work like with user stories, kind of with those. Sometimes it's just writing, writing a book or a long article or something like that, and you want to play around with different arrangements of how might I convey this, or projects you're doing, when, I don't know, we've had a bunch of projects around the house, the garden and so on, might have plants that, maybe radishes and I don't know what, lettuce go in pretty early and tomatoes are maybe a little later. And, you can kind of do your planning with that. But, I don't know. It seemed like fun to think about the algorithms to match up stuff, just, it's a little more, taking advantage of that supercomputer in your hand kind of thing. All right, Xcode refactorings. What I've noticed in using Xcode, and Xcode is the IDE for Objective-C and Swift on the Mac, sort of provided by Apple out of the box. The competitor I know is AppCode, which is from IntelliJ, with JetBrains people that do IntelliJ. And it's certainly more sophisticated with a lot more refactorings, and it's taking advantage of all the work they've done in C# and Java and other languages over the years. But Xcode is pretty common, and it has some refactorings. I mean, this is not the biggest list in the world by any stretch, but I thought it's kind of hard to tell, like, what do they apply to, or when do they work. And when do they work is maybe the real weird one. Like, I've noticed sometimes something I think would be very straightforward to extract, and it's like, I don't know what to do. I have no idea. Would you like to rename it? No. So I thought I would just do, this will be a short one. It would just be like, let's take a project. I don't even care what it does, but let's find somewhere where we can do a rename. Okay. Or an extract to function or extract to method or whatever. Just go through and try and do those, figure out the variations, and see what happens. And then some of the ones on the bottom half aren't exactly, there's some of them are sort of refactorings, but more generators and stuff like that. Maybe give those a try. Just that refactor menu, just see what there is. And the goal of it would be extract. I would try and work through an example and then do it from scratch as sort of a video demo of maybe taking, 60 to 90 seconds to demonstrate one of these. And in the end, I would have about whatever that is, 10 or 12 videos, 15 minutes to watch them all, and then publish them somewhere and, put them on my YouTube channel and publish that around the Apple community a little bit. And hopefully, again, I want to do some things that affect other people and help other people, affect them in a good way. Okay. And if I can figure out why sometimes they don't work, that would be interesting too. Maybe there's some feedback for Apple on that. I think there's a newer version of Xcode. I probably need to upgrade to get to that. All right. Let's see. Lately, I've been doing this Elm project, the Dungeons and Patterns, and creating a game in Elm. And it certainly revealed to me that I have gaps. There are topics, there are things I can do and things I understand. And then there are things I can do but don't understand. And then there are things I don't understand and things I don't even know about. It's not quite known unknowns, but, kind of on that order. So decoders are a good example of one that I can muddle through, but I don't have a deep understanding. So, I sort of know they're building a giant function, but I haven't just tracked it all the way through to see how that thing works. Parsers are somewhat similar. I don't know. I worked at I worked at Digital years ago, working on compilers for various languages, and taught compilers for a little while as well. And so I've got some understanding of parsers and stuff, but the functional languages have a somewhat different view. And I know Elm, I took a stab at doing this kind of parser combinator thing that I know you can do in Haskell, but I didn't get it to work in Elm the way I expected to. I'm not quite sure why. I know there's Elm parser packages, and it would make sense to understand that because parsing, it happens often enough. And then my final example is there's the notion of ports. And a port in Elm, as I understand it, is sort of a way to communicate to JavaScript outside of the Elm program. And I think what you're kind of doing is setting up a stream. Well, normally with Elm, you have this Elm architecture that turns, basically divides your work so that you have a view function and an update function and initialization. So you define the initial state. You define a state, you define what the initial state is, you define a view that can convert the state into HTML, and you define an update method that can convert a command in a state into a new state and optionally new commands. And I think the ports are kind of the same, that instead of everything just kind of being jumbled together, it's well split. And I think you're almost coming in the same way, just like you would get an update call that says, somebody clicked on this button, here's the command, here's the old state. What do you want to, convert to the new state? I think ports have a similar kind of connection. I think it's a separate function. Not 100% sure, but they definitely have a way to take something coming from JavaScript, feed it to you as a sort of event, and you react accordingly. So obviously I don't know much about the mechanics of it. I mean, I just kind of know it exists and what it's for. I haven't tried mixing JavaScript and Elm to any reasonable degree, so that's that one's a little open. But I know there's pieces of Elm I just don't understand too deeply, and I think it would pay for me to get that deep understanding so I can use these tools more effectively when I can. So I don't know. Kind of feel like that's necessary for me. Maybe not as exciting for somebody else. But anyway. All right. Next one is some music tools. And I started an Elm project, I don't know, like 3 years ago. And I play Mountain Dulcimer, which is shown on that computer there. It's a 3-stringed, usually 3 to 6 strings. You play it on your lap and you strum. There are different styles, but one style is you just play the melody note and you let the other strings drone. So people call it a bagpipe sound sometimes. And where you can play chords, or you can, there are other variations. But I do write some stuff on music and Dulcimer and music theory together kind of thing. And my idea is I would like to have something to kind of show what are the notes and chords and all that stuff on a Dulcimer fretboard. I say Dulcimer fretboard, and the thing is there's really, 4 or 5 common fretboards. There are a lot of variations, but there's sort of the original set, and then the original, the melody string was the only one that had frets. So a fret is a piece of wire you press against it, and that makes a particular note. If you're playing in that drone style, you only need a fret on the melody string. So they had what they called staple frets, and just like a staple you use in woodworking or something, maybe to attach wire to a fence or something like that. They would just put those staples in where the notes should be, and they had sort of a modal sound. So I don't know. I want to teach you all the music theory for it, but there are different kinds of scales, and the Dulcimer used a kind of weird one. That was the original. Then at some point they stretched the frets all the way across so you could actually make chords more or less. And then they also added another note to kind of fill out the missing note in the scale. And then they decided, it would sure be handy to have this other note, because sometimes you're playing on a key where that's the missing note. And so they added that one. And then somebody it's like, well, why don't we, guitars and ukuleles are chromatic. Why don't we just fill in all the missing notes? So on its own, it's kind of like the white keys on a piano, not starting on middle C, but starting on G instead. That's why you have a different kind of scale. And as you add these extra notes, you're sort of adding black key notes, so you can play different either different keys or occasional different notes that wouldn't normally show up in that scale or something. So yeah, that's 4 scales, and there probably are more. I don't know, but I need the flexibility for at least 2 or 3 of them. And my idea was I would show the fretboard, basically a drawing of the fretboard with the frets and their numbers, and then highlight things like light up all the notes where D occurs in this tuning. Okay, so you choose which notes to tune to. The 3 strings, like DAD is very common. So a bass D, a middle D, middle A, and a higher D. But if you know what the tuning is and you know the fret numbers, you should be able to find all the D notes or all the E's or F sharps or whatever. You should be able to find the notes in a particular chord. So A7 is A, C sharp, E, G. Okay. Again, don't worry if you don't know the music theory for it. It's no big deal. But, there's 4 notes you're trying to find. And if you know where all the A's, C sharps, E's, and G's are, you could pick enough of those. Usually you leave off the E if you don't have enough strings, like you only have 3. But A, C sharp, G, you could find all those, and you could figure out from that where could I make an A7 chord. Another one you do is if you play, say, an A7, it occurs in multiple places because you could, the A could be on the bass string or the middle string or the melody string, and the C sharp on either, on any of those, and the G or whatever. So you have multiple versions of the same chord. You have this with guitars even more because they've got 6 strings, so there's a lot of combinations, and so there are, normally a lot of ways to play a particular chord. You can play it high or low, and you can play it different notes on the bass or the middle or whatever. And so I would like to get some tools like that, and you want to use it in a couple ways. One is I'm doing some writing with it, so I have a weekly, like 5-minute music lesson I write, and sometimes I want to show pictures of what does it look like on the Dulcimer, not what does it look like in your normal music notation you might be used to. And it would be nice if I could just, highlight all the A7 notes and take a snapshot and drop it in my writing thing. Okay. Or I would love to do little animations of these things, like showing where the chords are. I would love to show you that the bass note of the chord is moving up to the different string, and just sort of relocating all the notes as it shifts its way up the Dulcimer fretboard, kind of thing. It would be nice to have a little video for that. Yeah. And I could see doing some regular music notation things too, but the fretboard one is very Dulcimer specific, and so that's where I'd start. Okay, so I haven't done anything to speak. Well, I haven't done anything recently on any of these projects, so I haven't even set up like projects or any of that stuff. So I think I'm just going to do stuff at random, just start somewhere. Let's take this. This might be like a one-day thing even. I mean, yeah. Okay. So what we'll do is we'll take some existing project, and I will just try one example and see if I can figure out I would like to characterize when does the function activate, or the refactoring activate, and then what options do you have when you do it, and just run through those. Okay. They're pretty limited here, but we can do it. All right. So let's go to Xcode. That is not what I expected. Okay, it's opening up another window. Let me choose a different project. Okay. This one is Mander, which was the gerrymandering project we did. I don't know, maybe, gosh, is it a year now? I don't know when these, let's see, show and finder. Okay, April. A lot of Aprils in there. Okay, so what is that, 9 months ago? All right, so let's close some of this. Okay. So I don't know how much to run you through this, but the idea okay, so I don't know if you've seen polyominoes. They're sort of like the Tetris shapes, and we want the ones that have 5 things in them. So the idea is, and I don't have a picture. Oh, I know where I have a picture. On here. Somewhere. Well, we're going to have to go find it. So it should be under here somewhere, like archive. Where did I put it? It's not yacht. Shanta's algorithm. Oh, how weird. Well, let's find, can I find a browser? Okay, so, gerrymandering, we can do this. Okay, yeah, this is kind of an example. Okay, so, imagine you have voters that are 40% purple and 60% green, and you're going to break them up into precincts. So a lot of states are doing their districting right now. Okay. So if this thing were kind of free, well, if it were fair, the greens would have about 60% control and the purples 40. Okay. If you broke them into districts accordingly, okay, and see how they're doing 5 groups of 5, okay, they've got 3 districts of all green and 2 purples, and so 60-40, okay. You could also do it unfairly so that they lose every district, okay. So 3-2 in each district, it's 60-40 overall, but green ends up winning 100% of the time. But there's another way to do it that is basically we're going to divide things up so that each district has 3 purple and 2 green. And it turns out we can make, well, in this case, we can make at least 3 districts like that. So you got 1, 2, 3, and then 2 districts where green has the majority still. So from a district point of view, purple controls 60%, even though they only have 40% of the people. And in these states that they're talking about the gerrymandering, that's kind of what's happened. They've chopped it up very funny, to make sure that they pull in people from various places. So my recollection is I lived in North Carolina for a while, and one of the districts they had going, it connected one city to another one that was like an hour away. And so there was this like 6-foot strip of land that followed the highway from one city all the way out, an hour and a half, whatever it was, away to another city, And so normally you want to say districts are compact because it's the people who live together who have similar needs. But here, to make sure that they divided up, those voters, they wanted to pack certain voters together. So imagine like this district, here that's sort of like mostly green, but well, I guess it's a small way, but they've arranged it in a certain way so that they stretch out to pick up as many of these as they can, because they don't want to waste, they don't want to give them another majority, or they want to use up their votes on one they've already won, and not give this sort of spare vote to another district, because then that would turn it turn it back into a 3-2 district kind of thing. Okay, so you do these things, and then this notion of polyominoes is, these are five dot shapes, okay, each one, and you can sort of define, I forget how many, but there are a number of was it like 23 and then 68 with reflection or something? I can't remember, but a number of different possible polyominoes, and then you have to do a tiling that comes out the way you want it to come out. I guess if you're on the gerrymandering side, you're trying to gerrymander it. Okay. And that's what that program does. Okay. And so this, I believe the way that you read this is the first row of an object, the second row, the third, the fourth, the fifth. So that's a vertical bar on the first column. Line 9, you got 2, 2, 1, and then the rest blank. So it's kind of a square with a bump on the side. Okay. And these are I guess these are the possible seeds. So 4, 8, 12. Is that right? Okay. But that's what we're doing, is trying to use these polyominoes to cover a board. Okay. And so it uses this combinations as sort of a backtracking. I think of it like a combination lock, but it's backtracking to figure out what are the possible ones. Now, the problem with this is, okay, this is big enough to be interesting. Okay. I broke it up into pretty small functions for the most part, but let's see who uses this. Bits of strings. Okay, so if I refactor, I don't know what that means. Okay, convert to computed property. No, that's not interesting. Okay, so if I wanted to extract this, I would love it to say let temp equals this stuff, or let bits of string equal the tiles on. But I can refactor this. Now, I don't know what it would mean to rename that. I just renamed the first thing in there. Okay. I can't extract it to a function. That seems a little odd to me, because I don't know. It just seems odd. Okay. Extract a variable. Well, okay. But I can extract method. Okay, and notice what it's giving me. Really, my only choice is, what do you want to call it? Okay, and I'll call it make bit strings. Now, I would not have guessed that this was the type of this thing, an array of reversed elements. Ugh. It's kind of... I don't know. Not an ideal declaration from my point of view, I guess. I'm trying to think of them as a string. It takes a string, it reverses them, it filters out the ones that are not white space and are not bars. Okay, so that's taking that big function I had and turning it into an array. Well, I mean, what this tells me is the name of the variable is not right. It's not converting them to strings. It's almost like to array or something. Tiles is a string. It's a pretty specially formatted string. I would almost say it's reconstruct. Okay. What is it giving? Gosh. An array of elements, which is an array of strings. Bit string to array. I think it's telling the truth. This is not a good name, though. Yeah, I don't know. But anyway, what we saw, let's see if we can do this one. Now, what I find unfortunate with Xcode is, for the most part, it doesn't explain to me why something is acceptable or not acceptable to extract. Like, why can't I extract it to a function? Let's see what it does as a method. Yeah, middle in out. Okay. So I don't regard that as an ideal extract because I'm mucking with middle. What if I extracted all of it? And I used to have keystrokes on this thing. Okay. Oh, this is too bad. See, I'm initializing middle here, and then I'm getting it there. Let me just manually do something. Okay, now can I extract this? No. Oh, that's too bad. I feel like not to toot AppCode's horn because I haven't used it for anything other than like a 5-minute demo, but I'm certain IntelliJ for Java and Kotlin and their plugins for C# would let you do this. It looks to me like middle is not used outside of the scope of what I have highlighted. Okay. So an I is not used afterwards. The only use of middle is here. So if this extracted something, yeah, that's really too bad. So, I mean, this is where I'm doing stuff that's not strictly, I'm sort of using the tool to bump me along, but I'm not using it right per se. Okay, but make middle. Okay. And middle comes in a string. Let's start with middle equals that. So I'm taking this and I'm moving it in. Okay. And then I would like to return middle. Okay, and I'm going to return middle. Okay, and now normally I would have a change signature and I would drop that out, but I have to do it manually. Middle is passed in, but it's never looked at what's passed in, and it's passed out, but we're returning it too. So let's do this, var middle equals make middle. Okay, and let's take this argument out. Okay. Oh, I have to make this local. All right, now let me run my tests. Because I've used this, now I have a sort of manual. Oh, I do it over here. Okay, so I've made this semi-automated change. It's probably a good change. I don't, bits of string is not making a lot of sense to me as a name, but how are you doing tests? Okay. Bits of string starters. Yeah, I don't know what's going on. Yeah, that's legit. Wow, you get away from for a month and you can't remember where anything is. Are you running or not? Oh, there it goes. All right, so while that's going, I'm going to take a minute and make some notes here. Okay, that was a happy ring. So I'm just going to say select something, use refactoring menu, explain why it does or doesn't allow it, demonstrate it working with variations if possible. Okay. So sort of the result of my investigation, I guess I'd say. Yeah, so I think I see this as a one session kind of thing. It might be worth doing, but it's not going to occupy us for a month or two anyway. All right. Tests all passed. And now I'm not planning to check this in. I'm just going to revert this. Okay. So I would say we've done this one. Let's pick another one. Well, let's do p-test while we're there. All right, but first, normally we take a break. We're 10 minutes overdue for it even. So let's take a 2 or 3 minute break, and we'll come back and take a look at p-test. Okay, let's see. So that was a slight experiment with the camera. See if I can get that showing for the TimeKeeper test. All right, p-test. So let's go back to Xcode. And I think I made a P-test project. P-demo? Well, I know I used it in Mander, so let's see. Demo tests. Yeah. Where's the code? P-demo app content view. Info preview. Maybe there is none. I guess there is none. Okay, so this is my demo of parameterized tests. So what I've done is I've created this example, and you give it input and output. And you may optionally give a message, and it implicitly gets a line number. Okay, so here I've got the input is the string 000. The output as an int 16 should be 0. Should be an int 16 0 if it parsed properly. Okay, and so this string is sort of an explanation. This type, notice the type is bracket input. It doesn't define the type. So you could pass a tuple, you could pass some particular kind of object, whatever you wanted. But then your test, the parameterized part of this is it's going to do some work with an assertion, and it can use the message, which we're not using. Well, we got the output, yeah, the message. So we can pull the message from here, which pulls the line number in the message. All right, so let's run this, and then we'll make some errors and see what happens. I think this is like the first version, so I believe I used some in Mander. Let's go back and see that. Oh, what's your problem? Unable to log in. Like, why do you care? I'm not making you sign anything. Ugh. Okay. Let's see what Mander had. UI tests. Didn't use it. Model tests. Well, I'm not seeing anything that looks like those kind of tests, so all right, so this one, let's record some notes. I need to find the latest version. Find John's feedback. Add assertions. Well, find, I guess, improve the parameterized testing and add assertions. Okay, so one project we had was p-test demo, wherever that got off to. p-demo. Oh, maybe I don't know. I'm not sure what happened to the signing there. There is p-demo in open recent. Okay. Let me try another one. Could be in here. I'm not quite sure what I'm looking for. Input. What's match case? No, that's not me. P-test. MSG. Okay, if I don't have any tests that use MSG, I don't think I have them in here. I wish I could remember what I used it for. I don't think it was these basic ones. Let's see. No, that's non. I really thought I had used it in Mander. Okay, swipe line. I don't remember what that is. I guess I just was playing around with different transformations, huh? Okay, definitely not helpful for this. Okay. I guess I can try blocked. I don't think it says heavy testing. Nope. It's just got a couple of kind of high level make sure things didn't change, kind of lockdown, pin down tests. Okay. Well, let's go back to pdemo. Let me try signing in. Okay. All right, let's try again. Run these. It failed. It told me I was logged in before, but okay, well, I don't know if this is enough. So another kind of assertion. Let's make a helper function for that, but it's something like inverse holds. I don't know. We'll get there. Okay. So what I'm thinking of is if I take an int, well, an int 16. Okay. If I take x equals 42, let's put that in quotes. My int let my int equal int 16 of 42 of x. Okay. And then let string equal, I don't know how we do to string. Do we have to string? No. My int. Okay. And then assert equal x and string. Okay. And the idea is okay. Do I have a browser? String describing. String unwrapped int value. String of int is legal. String of int 16 is not. Okay. Let's let this be my int 16. My int equals int of my int 16. I don't know. Maybe I can do it there instead. Okay, but the important thing is I'm starting with a string, I'm ending with a string. If the conversions are all okay, they ought to be the same string. Okay, and I ought to be able to go the other way too. If I start with an int 16, convert it to a string, convert it back, it ought to do it. So I'm applying f inverse, and I'm checking that the value comes back to the original. Okay. And I can see it's not waking up and it doesn't want to run my stuff. So there you go. I don't even know why it's tied to an account. It just seems weird, but that's the way it is. All right. But anyway, that's an example of another function, another assertion I would like. So really it's a function, an inverse function, and a value. Okay. So that I could generalize that. So a function, so I guess I would say this is the first one. Let's see how we can do this. Can I extract this? Kind of look at my last one, extract a method. This is to int 16. And then this function, this, which it probably won't let me extract. Well, let me do it. Let me inline it. Are you going to run? No. Okay. This I should be able to extract. Extract method to string. Okay. And now I want to take this is this useful? I don't know. Well, what I want to do is I want to define a function okay, if I took x how can I do this? Well, if I did that, that's not quite right. Yeah, let's do this. Okay. Let f equal 2 int 16. I think I can do that. The type of f is... Thanks. Can I... Nope. That's not it. Okay. Let's apply f to that. Let f inverse equal to string. And this is f inverse of that. All right, now move this up to go with the other values. I hope it lets me extract it. Yes. Okay. So assert inverse works. Okay. You give me f, x, f inverse. Why I picked that order, I don't know, because it's not what I want. Actually, maybe I want x last. That. Okay. Right. So this is sort of the shape I want, but I don't want the values to care. I want them generic. Okay, so if this were function, do I put it? Where do I put it? Well, struct. I never remember. Is it here? Input to output. Okay, this is really input to output. This is output to input. And this is input. Okay, and yeah, hopefully conforms to equatable. Input. Okay, let's make it input conforms to equatable. Okay, so that sort of demonstrates how the generics are nice. You know, I can I can generalize this function across those things. It told me what I was missing, but it successfully works here, and I could do another one that was dealing with numbers or some other type completely, and each one would get mapped to input as a set on per call basis, which is cool. All right. So yeah, so I think this can be done. I've got some cleanup to do. Okay. Yeah, P demo, I guess. We'll start there. So another one was inverse. And I really got to dig through my notes because I have about 10 or 20 of these functions defined somewhere, but in my notebook sometime in the last 5 years, one of those. Okay. Let's save this for a moment. P-test. Let me just take a snapshot of something here just to, I guess it's over here. Well, let's just do it with a 4. I'm just trying to get a flavor, so we'll just get a flavor. Somewhere I found out there's a configuration for screenshots. You can tell it to write to a different folder, so I've been having it do that instead of slopping up my desktop. Might be worth a look if you take a lot of pictures, screenshots. Okay, yeah. So that's just a reminder. All right, so we've got this one done. No, we haven't done that one. We did. Where'd it go? Xcode Refactorings. Okay, so I'll move this to the bottom and this to the bottom. Card pile. Oh, what's the... Oh, we're probably due for a break. So let's take 2 or 3 minutes. And I'm going to play with the camera some, so don't be disconcerted. But let's come back and tackle another one of these. All right. All right. Let's tackle this one. I guess what I have to do is I definitely need to confirm that some parts are working. This should be easy to confirm. Let's try it. All right, and I'm going to try and shift camera angles. If I do this project for real, I'll set up a better table for this, but at least you get some view of my side desk with this. Okay. And all right, I say I don't have a mic on that one. Let me add a mic. Okay, test this one. Okay, check. Yeah, it looks like we're getting it. This one, I don't know what that is. We'll turn it off. Okay, yes, that's my desk. Okay, so the photo cube is just one direction or another slides off. There's only 18 choices, so bound to find it, right? Here we go. Okay. So I think
I should be able to fit my electronics in this cube. Okay.
Now,
I've had this thing for I don't know, my whole life probably. I think I got into electronics when I was about
probably 15 or so I might have
gotten this thing. And I show, okay. I hope it has some juice left. So I have these two probes. Where's my view? Okay. I don't know if you can see, but the meter is showing almost zero resistance. It showed like 1 ohm, which, yeah, you can see it going down there. So all the way over to the right is, it has no resistance. Okay. And to the left, it does. Okay. So let's just play with one of these tilt sensors. Actually, maybe I'll get 2 out. All right. Okay, so so it has the 2 leads on it, and somewhere inside, I don't know if you'll be able to hear it.
I can hear it rattling
just ever so faintly. Okay, so what I'm going to do is I'm going to hold it in a certain direction and test the lead. So I'm holding it more or less that side up. Right now it's infinite, and it's going down to basically near 0. Okay. If I tip it the other way, so the other end is on top, it stays at infinity. Okay, but if at some point the ball goes in, okay, so somewhere, that's kind of, yeah. Okay, but tip fully this way, it's infinity. Tip fully this way, it's 0-ish. Okay, I don't know if I can do 2 at once. Let's see if that one's not doing it, that one's not doing it. Okay, so if I do them both, I should get infinity because neither one's active. If I do this, either one should be active, and then I'm gonna tip this enough. Okay, this one's off, this one's on. If I tip it the other way, this one's off, this one's off. On, off and on. Okay, so if I do the or of them, all right, I'm connecting them both. If it'll reach, or they're both on, but by itself that one's off.
Okay, so my hope is I can embed this thing.
Okay, so if I do this, it takes some getting used to. This should go on from one and off for the other, or something like that. You know, I feel like I should be able to get enough that one direction they're both off, one direction they're both fully on, and one direction they should be one or the other.
And that's going to be a critical test early on. I don't know if I can make it now, but it was promising enough. Okay, so I've got some Play-Doh kind of stuff, some colored clay. I don't know if it'll dry or not, but I think I can mount them in a ball of that and play with trying to get the angles crisscrossed in a way that three directions that all six positions of this cube show different bit combinations on that. All right. The next test, and I don't think we'll go with that right now, but I'll pull things out.
Okay, so this is just a little bag of parts, and here's the little doodad. Okay, it's got a, I don't know if I can peel off enough to see that, but it's a breadboard underneath. It's got little holes, and basically the wires, there's basically a path from each pin to one of the holes on the breadboard. Okay, they're all independent. Okay, but I don't know if you can see. A little hard to see, but they show a sample circuit. So if you plug in the LED here and a resistor here and a battery here, you can it'll do whatever it does. I don't know what that does. And then there's a power cord.
I'll dig it out later. It's a USB power cord.
See, the end of that thing has a little micro USB slot. Is that this way? Okay, yeah, there's a little micro USB slot there. All right.
I need to verify that Particle.io, which is the company that has this, is still connected and still works. And then I got to figure out how do I get power to this thing. Can I set up a battery pack or whatever? I don't know. But anyway, someone gave me this little guy. I don't know. I think it's probably 10 or 15 bucks to get one if you can still get them. But they were just giving away samples at a conference or something like that. So kind of cool.
Okay. Let's go off the camera.
Okay, so I guess I should capture some notes. Whoops. Should be able to get 4 with 2 bits, right? But I don't know if tying them together, that shouldn't matter because it should be 3 independent outputs. Okay. Need to verify photon. Can talk to home office. I'll say backend. All right. Pipes game, this one I can explain quicker. I think what I explained is probably enough. Let me just bring up a project. Sorry, let me hide this sec. I don't know how long I had the break set. I hope. I've lost my chat window. Okay, well, I don't know if I hope I showed off this stuff I wanted to, but we did the tilt sensor and the photon a little bit. The Elm one decoders